We're given this series, and we want to get the general form of it, and then see if it converges or diverges. Okay, first thing to notice is there in the denominator we have 1 times 3, 1 times 3 times 5, 1 times 3 times 5 times 7. So this is just multiplying odd numbers. And then the numerator we have 1, 1 times 2, 1 times 2 times 3. So that's going to be n factorial there. But then we have 38, 57, 76, and over here we have 19, which 19 is obviously 19 times 1, 38 is 19 times 2, 57 is 19 times 3, and 76 is 19 times 4. So with that in mind, we're going to factor out a 19, and then things look a lot simpler. So on the top, we said we have k factorial, and the bottom, we have basically, another way to write this is say 2k minus 1, and then double factorial. But, yeah. But we're just going to write it like this, 1 times 3 times 5, all the way up to 2k minus 1. Now let's see whether this series converges or diverges. And to do this, we need to use a ratio test. So we'll look at the limit of the k plus first term over the original, the kth term. And we're just going to be doing a little bit of organizing. So basically, this goes to the top, and then this goes to the bottom here. But we're going to separate it into two separate fractions. So the 19k plus 1, and then on the other top we said it was the 135 all the way up to 2k minus 1, and then this was a 135. This simplifies to 2k plus 1, and then over 19 times k factorial. Now we can do a bunch of simplifying. So we have the 19's canceling. K plus 1 factorial is the same thing as k plus 1 times k factorial, which k factorial cancels. So you're just left with k plus 1. And over here, the previous term to 2k plus 1 was a previous odd, which was 2 away. So that would be 2k minus 1. So everything prior to that will cancel. And you're just left with 2k plus 1. So on the top you have k plus 1. At the bottom you have 2k plus 1. The limit as k goes to infinity is 1/2. That is less than 1, which means the series converges by the ratio test.